Hi all, thank you for coming to the last session of the day. I am between you and happy hour, but there is an interactive presentation, so if you're just hoping to have somewhere to sit and not pay attention, it's not going to work out so great. If you're hoping to learn stuff, you're in the right room. This presentation will be available on Speaker Deck immediately following the presentation. I don't like to post it first because then people look ahead and see the answers and don't learn as much, which kind of defeats the point of it. But you don't have to worry about taking notes. Within a few minutes at the end of this presentation, the whole thing will be online. So a quick commercial break. I write certification books, and I also wrote a new book called Real World Java. If you're in this room, you're likely overqualified for it. It's meant for students, career changers, people who used to do a different language, people whose employers have been stuck since Java 8 since the dawn of time. If you know any of those people, tell them it's a great book. Some of the material in this presentation does appear in the certification book, but I only copyright on that, so it's totally cool. We're going to be covering 4 blocks of stuff. After each block, there's some review questions, which is that interactive part that I just got through threatening you with. And it helps reinforce the learning and highlight the tricks. There are also some slides that I'm going to be either skipping or glossing over unless people look super puzzled. I included them in the deck anyway, so that if people are puzzled, I can go into them in more detail. And also, so if you're looking at the speaker deck later, you have that additional material. So you might be wondering why we're talking about Java 21, given that most of this conference is all about 24. And the reason for that is the certification is tied to the LTS versions of Java, and the latest LTS version is Java 24. Also, they don't start on the certification updates until it came out. So the Java 21 cert came out around the time of Java 22, Java 23, and I expect the Java 25 cert to come between Java 26 and Java 27. So the 21 cert is current and good for a while. Also, certs don't expire. If you got certified on JavaOne 4, congratulations, you were still certified. Your knowledge isn't particularly current, but your cert is still valid. So in this block, we're going to be talking about text blocks, sequence collections, and string APIs. So can anyone tell what's wrong with this example? Yeah.
Well, the first double quotation is wrong.
Yes, it is missing a double quote. Exactly. And it doesn't compile because it's missing a quote. And that's problematic because you look at it and you have to stare at it for a while and then you have to sit there and count quotes, and that's not particularly fun. So text blocks were designed to solve this problem. This is the same code at the bottom written with a text block, and it's a lot more readable what we're trying to get at. It's a CSV. It's got quotes around the word session, because. But you can see from the format of it what's going on here without any confusion and without the excessive backslashes and line breaks and everything that's going on. So text blocks are super useful in understanding the code and making it easier to read. The way text blocks work is they begin with triple quotes and end with triple quotes. The beginning triple quotes have to be on their own line. The ending triple quotes can be on their line but don't have to be. And if you put it on your own line, it means that you end with a new line. If you put it on the same line as the rest of the string, you don't have a trailing new line. So you get to control that. So text blocks, super simple. The most important thing to know is that text blocks are strings. Everything you can do with a string, you can do with a text block. So all the methods we've had available since the dawn of time, you can pass them as parameters where a string is. It is a string. It's just a string that's easier to write and understand if you've got multiple lines or quotes or anything funky. Unlike a regular string, you have to pay a little more attention to the white space with text blocks because there's different types of white space. In this example, there's what's called incidental white space, which means that it's white space, but it's not part of the string. It's there to make the code easier to read and understand. After all, you don't want your string starting way back at the beginning of the line. You want it to follow the indentation of everything else that's going on here. So the way Java deals with this is it draws an imaginary line to the left of everything confined there, whether it's the real string or the closing triple quotes. Anything to the left of that line is incidental white space and not part of your string. By contrast, anything to the right of that line is essential white space and part of your string. So in the XML, we don't want to lose all the white space. We want to keep it because it's going to make our string readable and possible to understand. So we've got our essential white space there. We talked about ending lines already. There's a new character for control, which you can use in regular strings too, because as we established, a text block is a regular string, which is \s. A \s is a space. Now, in a normal string, you're not sitting there typing \s because it would be easier to type space. But in a text block, the end of the string is significant, and if I don't put that \s, I don't have all of those extra spaces that come before it. So all those blank spaces that you can't see and the \s are perfectly good string characters and let me have a bunch of silly trailing space after my name in this example. Tabs work the same way they always do, although you can't see them. And / lets you continue on the next line without a line break, just like property files. So that's nice they used a syntax that was familiar to us. If you don't specify a \, you get a line break. And most of the time with text blocks, that's what you want, because you want it to look like what you're seeing. But you also don't want your line of code to run on forever. So it's nice having the option of doing that. So for new lines, I get a new line for free at the end of every line. And if I do a \n, I get another new line, the one I specifically requested. Here I get one new line in between my name because it's in the middle of the line, so I don't get a bonus one in the middle of the string. I get one after my last name. And in this case, there's no line break at the end because my triple quotes are on the same line as the closing, so I've opted out of it. Another fun thing with text blocks is escaping the 3 quotes. Now that 3 quotes has meaning in a text block, you can't have 3 quotes in your text block. Right? Just like XML, you can't close the string, you can't close the comment. So what you can do is you can escape all 3 quotes, or you can escape just the first quote, and that's enough to tell Java this is not in fact a triple quote, don't worry about it here. There's some index of overloads that have nothing to do with text blocks, but since I was talking about string, I figured I'd throw them in there. It's rare to need these, but it's nice to know that you have that option to have more control over your index of. Also with index of, if you're using index of, think about whether it's the right way of doing it. I find that about 70% of the time when my teammates are using index of, they really should be using replace or something else and aren't because they're afraid of regular expressions or other methods. So think about index of whether you should use it or not. Sequence collections are here because they're on the certification, but there's so little to say about them that they get like 2 slides. So in Java 17, we have list, queue, set, and map. This should be familiar to any Java developer because it's been there since very close to the beginning. In Java 21, they added sequence collections to some of them. So you can see here that we have our collection types, and they made the ones that make sense to be sequenced into sequence collections, so they have some extra APIs available to them that are very rarely useful to you in real life, but could be if you're doing something super specific where you care about the order. As an example of that, we have a hash set here, and we're adding Donald, Mickey, and Minnie to it because I like Disney, and we're asking for the first one. Does anyone know what that outputs? Yeah, me neither. It's up to the JDK. So that's not useful. So the idea with sequence collection is you can have a deterministic order, so you do actually know what's going to happen. All of the classes are in black are sequence collections, and you can call extra methods on them. They keep the existing structure we've had, so a hash set is still a set. Black just means class. It's the ones that implement. So a tree set is a sequence set. A hash set is not a sequence set because we just got through saying there's no sequence. I am so tired. Sequence set, sequence collection, and sequence map are the things available to you. There's no such thing as a sequence list because it wouldn't have any different behavior than a sequence collection, but it's still sequenced. So we have a bunch of methods available to us, and they all pertain to order. So if you say you want to get the first one, my Mac has decided it wants to update. I'm going to say no because I'm giving a presentation. It's not a good time. Also, I'm on Wi-Fi. I don't know why it thinks this is a great time to update. Sequence set lets you reverse the order, which is nice, as does sequence collection. So that's I really want to change it to not be the original order. And map has a whole bunch of things. It has the reversed, and then you can get sequence collections for the keys and the values, and you can also get all of the first and last stuff. So now when I ask linked hash set, which is a sequence collection, to the first element, I'm going to get Donald because it's specified behavior instead of asking iterator.next and who knows what happens. If I call iterator.next on a linked hash set, I still don't know what happens because iterator.next is not a sequence collection and is not defined. So now let's review or see if I can trick you depending on how this goes. Which of the following is true about this text block? For all these multiple choice questions, we are not going to answer out loud. We're going to do it via show of hands so everyone gets to participate. So read this for 30 seconds, and then I'm going to start reading the answers. All right, do we think this has incidental white space? 3 people, 4 people. Do we think it has essential white space? Few people. Do we think it has both? Some of you raised your hand twice, so I think you covered that already. And who thinks it doesn't compile? A lot of you are tired. We're going to have more of these. It's okay to participate. Nothing happens if you're wrong. This has incidental white space. I'm so tempted to walk over there and point to it, but I was told there's a line here that I'm not allowed to cross. So if we imagine a line where select, from, where, and the closing quote are, that's the line that it's looking at for whether it's incidental or essential. So everything to the left of that line is incidental. And those of you who raised your hand for incidental got it right. To the right of that line, there is no more white space. It just starts. So it's just A in this case. There is no essential white space. There is, of course, white space between things, like between the where and whether, but that's not significant in the space of things. That's just normal string white space. That's unlikely to confuse anybody, so it doesn't get a special name. All right, let's try this again. We have another string. It's a little bit different this time, so let's think about its white space. Okay, who thinks it's A, has incidental? Few people. Essential, B? A few more people. I'm not going to ask C because I saw some hands both times again. And who thinks it's D? Yay! It is, in fact, D. This was that trying to trick you thing. You can't start a text block on the same line as the triple quotes. It has to be on its own line. So this does not compile. If it did compile, it would only have incidental white space, though. Okay, what is true about this one? It starts on its own line, so this is better. So who thinks this is A? Nobody. Good. Who thinks it's B? Few people. Who thinks it's C? No, but one person. And who thinks it's D? This code does compile. And this code has only essential white space. That closing triple quotes is all the way over there. If you imagine there was a space before it and said there was incidental, consider yourself correct. I don't know how to represent that on a screen. But it has a lot of essential white space because all the white space that's to the right of those triple quotes is essential white space and will be preserved. So if I print this out, I have a super, super, super indented string. Okay, what's true about this text block? Hopefully this one's easier because I tricked you before. Who thinks it has incidental white space? Nobody. Great. Who thinks it has essential white space? Nobody. Great. Who thinks it doesn't compile? Everybody. Right. This is the same problem as the previous one. It has the code on the same line as the opening triple quotes, and you still can't do that. The reason I have it as a separate example is this one is way more tempting, right? Because it's like, oh, I have a string. I can just make it a string just like I can with everything else. It's like, no, you can't do that. That said, in this example, it could be a regular string because it's one line and it doesn't have anything special in it anyway, so I didn't get any benefit from making it a text block. But since I chose to use the triple quotes, I have to honor the rules and conventions around them. Okay, and we've got one more question, I think. Two more questions. Text blocks are fun. How many lines do we think this one prints out? So let's take a moment to count them. Who thinks it's A? B? A lot of B's. C? You got it right. It is C. So we've got on select star new line, we've got 2 line breaks. The new line that I said explicitly and the fact that it's the end of the line. Then we have on from my table, we have another one, the implicit line break at the end of the line. And then, 1, 2, 3. Oh, right. And then we have the other line break because there's the new line at the end of it. Did I mention it's tricky? Also, I am very much a morning person. So I would never take the certification test at 5 p.m. I would fail. And then our last one, this one I'm going to answer because I didn't really talk about it, which is how many escapes can be removed without changing the behavior. I can remove the 2 around name, and I can remove one of the 2 with the triple quotes with value. I need to keep one of them because it's triple quotes, and I need it to be escaped. So now that I bored everybody with text blocks, we're going to talk about records and sealed classes, which are interesting. With records and sealed classes, we got another feature that has absolutely nothing to do with records and sealed classes, but was necessary in order to implement it. You can now have statics and implicit statics like interfaces and enums inside of methods and classes. This used to be illegal. It's legal now. Doesn't buy you much, but it's good to know that you can do it. And if you're taking the cert, it's important because obscure little things like that are important. So if I want to make a class immutable, I have to do a whole bunch of stuff. I have to make the fields final and private. I have to make sure I don't provide setters. I have to make sure there's no subclasses, so either make the class final or hide the constructor, and then I have to write a constructor taking all the fields because there's no other way of setting them. All right, fine. I've got a list of things. I've been a developer a long time. I know how to do these things. If I want a POJO, I have to make a constructor, I have to make a toString, and then I have to do hash code and make sure I follow all the rules, and I have the equals, and I have to make sure I do all the rules. Or I can use hash code builder and equal builder because I don't want to deal with that. There's a whole mess of stuff. But if I want an immutable POJO, I don't have to do all of that anymore. I can just create a record. One line. I'm creating a record called book. It's got two fields, title and num pages. It's immutable. It's a POJO, and I had to write one line of code. I know there's two lines here, but I'm not counting the closing bracket as a line of code. I could have put it on the other one. So I'm going with my one line. So I have my new type here, record, and I got a lot of stuff out of this. It's automatically final. It automatically has private final instance variables. It automatically has accessors. It automatically has a constructor, and it has a correct equals and hash code that use all of these values. Finally, this is great. A lot of the time, this is all I need, and I don't have to write this whole mess of code, and then I don't have to argue with the code coverage tool about whether I've covered it, because it's one line, I've covered it. Yay. In order to use the record, I mostly use it like a regular Java object, so I can call toString on it. The mostly is because the accessors are not getters. They have the same name as the field, so I'm calling title here instead of getTitle. If I hate that, I can write a getTitle method that calls title and have everything be the same, but it's easier to get used to doing this so you can have super short records. So I covered no get. So I output this, and it does exactly what I would expect it to. It even generated a useful toString for me without having to do anything. But if I don't like that, I can override these methods to do whatever I want. So I want the title to be in quotes because I like quotes. I can tell it to do that for me. I can add new methods. I can override methods. I can do anything I want because it's Java, as long as I keep it immutable, because records are immutable. So that's nice to know that I'm able to do. Now, it's not really immutable in the same sense that if you followed all those rules before, it wasn't immutable. If I put in a list of strings, my list of strings is not immutable unless I take care to make it so. So I still have to deal with a copy constructor, just like if I was writing this by hand. But there was a lot of plumbing I didn't need to write, and that saved me time. There's a new thing in Java with records called a compact constructor. You can't use a regular constructor with records because that would give you too much power and you could break the whole it's immutable thing. So instead you have this compact constructor, which you'll notice has no parameters, and it lets you mess with the parameters on assigning them. So I've solved my immutability problem. I made an immutable copy of my list, so now my list inside of my record is in fact immutable, just like I wanted it to be. The access must match between the record and the compact constructor for it to make sense. Then we have sealed classes. A sealed class says that everything underneath it must be one of three types. It can be final, in which case there are no more subclasses. It can be non-sealed, where you're saying, I'm cool with subclasses, don't worry about it. And it can be sealed, where you recursively repeat this process. So I can have a sealed interface here, time of day. And I'm saying that it only permits morning, afternoon, and evening, and there are no other times because I'm not a night owl, so I don't want them. And then I have, implementing that, I have a non-sealed class for morning and another one for afternoon. And then I have a record for evening, which works because records and enums are final automatically without having to do anything. So nice and easy to use. Perfect. I'm able to use Instanceof with this. We saw a whole big thing about Instanceof this morning, and it works the way you would expect it to. Great. So now we've got some review questions before we go on to the next topic. How many lines of code do you think have to be removed for this code to compile? Let's take a little to look at this. Who thinks it's A? Nobody. Good. You've noticed that I'm the master of trickery here. Who thinks it's B? Okay. C? You all got it right. It is, in fact, C. Set type is not a thing because it's immutable, so there's no such thing as a setter. And get type is no good because it's type. Since it's a record, we don't get a getter unless we've made it so, and my record is one line. I've certainly not made it so. This one is not one I expect people to notice, but it doesn't compile because the record and the compact constructor are not the same access modifier. This doesn't come up much, but if you forget about it, it's like, why does my code not compile? Oh, okay. This one is more interesting, so let's see if we think this one compiles. Just do thumbs up, thumbs down. Thumbs up if you think it compiles, thumbs down if you don't. Yeah, this code does compile. It correctly uses a compact constructor. And compact constructors are immutable because they run before the initial assignment, just like a real constructor would. So it's fine to make it uppercase in the compact constructor. It would not be fine to try to make it uppercase later because it's final and you can't change it after the fact. And it correctly uses type instead of get type, so all is good there. Okay. This one is a perfectly good example of compare to. It's meant to show that you can, in fact, implement other interfaces and still use records, and that's really nice and convenient. How many compiler errors are in this code? This one is 2. This one's not that interesting. It's not final or sealed or non-sealed, so it doesn't meet the criteria here. Okay, so now we're on to section 3, and we are running perfectly on time. This is amazing. Instance of switch exceptions and pattern matching. Who's been to a talk on this topic today? Okay, so some of you. So there's a lot of stuff here, and what's cool about this is you can see how preview features are working because there are a number of previews. The pattern matching for switch has 4 of them because after the first 2, they found a problem with pattern matching and had to start over. So it was preview 3, but it was also like logically preview 1 because they were testing new syntax. But that's a testament to the preview features working because once you put something in the language, we all know it's never changing. So by having it as a preview feature, it was able to be tested and vetted, and then what we got, it was actually useful to us. So we've got pattern matching for if. Back in the old days, we would write if number instance of integer, all right, let's create an integer, and then let's cast num to an integer, and then let's print it out. Like, that's a lot of ceremony because we just established it was an integer 1 line ago. What do we have to do it for again? And the same thing with double. The second half shows it with pattern matching. If num is an integer, set num as int to that integer. Now I've got my integer. The same for the double. So we're telling the compiler to do these things at the same time. Right? Check you can cast it, and while you still remember the answer to that, give me a new variable that represents that new type so I don't have to do it again. It's guaranteed to be safe, I can't do it wrong, and I have less code. I like having less code. The num as int or num as double is known as a pattern variable, and it's scoped inside of the check. And I phrased it as inside the check instead of inside the if for an interesting reason that we'll see shortly. So the first half of this works the way you would expect it to. We're checking if num is an instance of double. If it is, we're calling a method that only exists on double. Perfect, it's good inside the if statement. Now on the bottom half, we have this if num is an instance of double or double int value. Well, that's no good because num might not be an instance of double. And if it's not an instance of double, I have no business calling double int value on it, so it doesn't compile. So when you see ors, you got to be super careful because you have to make sure that it's something that's guaranteed to compile in order for it to work. And in this case, it doesn't. So here we have 2 if statements. The first one is checking if num instance double n, and the second one is doing the same thing for integer. And this is totally fine because they're both scoped to the if statement in this case, and I'm allowed to reuse variables. Great. Then we get the one where this made my head spin the first time I saw it. It first checks if num is an instance of double, and then, oh, sorry, it's the next slide that made my head spin. This one's fine. You can't use it outside the if statement because that was the guard clause. This is the one that made my head spin the first time I saw it, and then it started to make sense. Here we've got a not. So if num is instance of double n, continue. If it's not, return. Now once I've gotten out of the if statement, I've guaranteed that n exists and is a double, and I'm still allowed to use it. And the first time I saw that, I was puzzled because I was so focused on well, I had an if statement. But what I really have is a guard. And what it's saying here with the guard is that if it's not a valid match, return forget about it, and now we can treat it as if it's good. So you have to remember that it's not scoped like it is with loops and if statements of the past. It's scoped by logic. And that makes you have to think about it when you do stuff like this. That said, I would not write code like this because if I did, my coworkers would have to go through the same learning curve. And when I saw this the first time, I was like, that's crazy. I even said it in a presentation. It's on YouTube somewhere. So you don't want people to have to go through that much thought, but it is good to be aware of how it works because it helps you understand the feature better. So here we have, we can't do this because n is still in scope. It was in scope when we did the first print line, so it hasn't gone out of scope for the if statement. Can't reuse it there. Now we have reusing a variable without that whole if statement nonsense. So I have num as int, and then I set num as int to 6, and I print it out. I am allowed to do this. Num as int is not final. Don't recommend it. This is confusing. But it is legal because it's just a variable, and you can do whatever you want with a variable. Then we had a behavior change. So in this case, this code compiles in Java 21 and not Java 17. And I think that's because someone thought better of what would happen to it. It was always a bad idea, but it was interesting that you could check something that it was the same type, and now all of a sudden the behavior changed. But it is still backward compatible because it still compiles. It compiles. It didn't break, but it was bizarre. So now we have our switch statements. Now that we're done with instance of, we're on to switch. So this is your classic switch, and we all know this is no good because it doesn't have a break in it. We need to have a break or it falls through, and I didn't intend for it to fall through, and yuck, who wants that? The newer switch statement helps with that in that you don't have to have the break nonsense. Instead, you have an arrow, and it chooses the one that applies. So I'm saying if it's Hallmark, print Kansas City and be done. If it's Crayola, print Pennsylvania and be done. Otherwise, print anywhere. So much easier to read, great to use. I can also set up multiple values with a comma, and that was added to the traditional switch as well, although it's less useful there. Then we have switch expressions. And you might be looking at this thinking, but the syntax is the same. And it is. The reason it's a switch expression is because something is being done with the value. In this case, it's being stored in a variable. In theory, you can pass it to a method, but it looks terrible, so you shouldn't. Since I'm storing it in a variable, I have to guarantee that all cases are addressed and the switch statement is exhaustive because I need something to put in the variable. I can't have an undefined variable. And I'm okay here because I have a default, but it could be an object or anything that is guaranteed to match. With pattern matching, I have to be careful and make sure again that it's exhaustive. So I'm starting out with null, then I'm checking if it's an integer above 21, you can gamble. If it's any other integer, can't gamble. String, I'm checking 2 values, and then I'm testing the generic value, and then I've got a default in case it was some type I wasn't expecting. This is exhaustive, and I have the guard clause with the when to make sure that I can specify any expression I want and have it be super useful. Order does matter, so I have to make sure that I'm checking things in the right order. Here I'm saying if it's null, cool. If it's any integer, you're too young to gamble. If it's any integer and you're over 21, well, you can't get there because you already said you were too young to gamble. Nobody's getting to this point. So you got to make sure, you, just like with other things, that you have the code in the proper order so that it works. Then we have enums. Enums work with switch statements as well and switch expressions as well. And they're really useful there because enums are exhaustive. We know what the enum values are. They're the 4 values in the enum. Surprise. So here I don't have to have a default because Java's smart enough to know there are no values. And if I add another value to my enum because I've invented my own deck of cards, I would have to add it here, a default or my 5th enum value, because Java would be like, hey, your enum doesn't compile, your switch statement doesn't compile anymore. That's no good. Here I have my default because I'm not having an exhaustive switch. That's fine. Okay, now we have pattern variables. Pattern variables, aka the I, are good for the case statement, the line they're on, so I can keep using I to my heart's content because each of the cases are separate. Yay, that's actually logical. It's nice when that happens. You can write complicated stuff with yield. Spoiler, you should never do this. Unless you're writing something super specific, this is hard to read and it doesn't help anybody, but it does exist. Okay, and then we have some more stuff about yield that it will be in the speaker deck, but you don't care about it for the purposes of today. Finally, we have record patterns. Record patterns are fun because they work like the instance of that we just learned about, so they're easy to understand, but we're able to do the decomposition on 2 levels. So I'm decomposing card, but I'm also getting the 2 parts of my record into suit and rank at the same time, and I can refer to them directly without having to call the methods. That's nice. I like that. You can nest as much as you want, and you can get those deep low-level variables as much as you want. And you can do the same thing with switch that I was doing for enums and integers and strings. It's just Java, and it works the same way. Yay. It's nice when that happens. So what can't you do? In the switch, x can't be a Boolean, a float, a double, or a long. It can't be underscore right in Java 21. But it can be in 24, which came out today, and it can be in 25, which is the next LTS and the version of the cert. That was something that was a preview feature. So this is a good example of if you do take the cert, it's super, super, super important to practice with the version of Java that you're taking the exam for so that you don't learn stuff like this and then get a question wrong. And expanding non-records are coming at some point. As of Java 23 and 24, it didn't say what version, so I don't know when. Another set of review. So this one, I'm only going to ask select ones because I don't want to run out of time, and I know, but nobody's staying once the beer is out. So in this case, you have to remove 2 lines. The string has a problem that it's in the wrong order. I've tested string before. I've tested the ones with the guard conditions, and that's no good. And also, I can't have both object O and default because those are both fall-through cases, and there's no scenario where one is going to match and not the other. So the compiler's like, yeah, this is no good. You know, you've got unreachable code. I don't know what you're talking about. And when the compiler doesn't know what to do, it drops the problem in your lap. Okay, next up, we have one that I will ask. It's not so complicated. So let's take a look at this one and see what we think it prints. All right, who thinks it prints A? Yay, you got it right. It prints A. This is not a trick. Robot is a string, so it prints X. Robot is not an integer, so it doesn't print Y. And robot is set to 694 before any of this begins, so it does print X694. Shout out to my robotics team. Good luck to us on Friday. Okay, now we've got another one which shows that you can implement equals with the new instance of. This is a valid equals method that fulfills the contract of equals, which is so cool. Because if you've ever written equals by hand, you remember there was a whole ceremony to it. And mine is 1 line. Well, it could be 1 line. I wrote it with an if statement, but this could easily have been 1 line with an and. And it's like, that's nice that you can have an expressive if statement now. I like that a lot, and I use it for real. Here we have 2 problems that don't compile. The last 2 have that or thing that I brought up earlier, that it's not guaranteed to have x be a value, so you can't use it. That's no good. This one's fun, so let's do this one. All right, who thinks this is A? 1 person. Who thinks it's B? 1 person. Who thinks it's C? Nobody? Who thinks it's D? And everybody else is in stunned silence. It is, in fact, C. The if statement creates a variable called length, which overrides the length that is an instance variable of stored. So while it runs the if statement and sets length to 2, it's setting the one that's only scoped to the if statement, and the one that's an instance variable happily remains 8. Then when it prints out the length, the only one that's in scope is the instance variable, so it's 8 as if none of that has ever happened, which is good reinforcement for why you should never set one of these instance of pattern matching variables so that you don't get confused. And this one shows that you can express your records in different ways. The first 3 of these compile. The first 2 show some decomposition. It shows you can use var. And the third one is only the type. The fourth one is not a thing. It's trying to trick with invalid syntax. We now have our last section, which is shorter than the other sections. So I am 100% on track, and we'll even have time for questions. Yay. Who's heard of virtual threads? Who's used virtual threads? Just me. All right. And to be fair, I use them for the book. I haven't used them in production yet, although my co-author has because he's on a later version of Java than I am. So we started out in Java with threads. Threads have been around forever. I don't remember a time where there weren't threads. And threads were unwieldy and hard to use. So they introduced executors in Java 4 or 5, and they were easier to use. But they were still slow. And now we have virtual threads, which are way better. And luckily, these things build on each other, so you still get to use threads and executors even when you're using virtual threads. So why we need threads? I'm writing a program. It's making a bunch of REST API calls over the network. So I have my program do the calculation, and it's calling the REST API, and it's like, all right, well, while we're waiting for this REST API to come back, the CPU is like, I'm bored, I've got nothing to do. And the network's like, yeah, I'm waiting for a reply, tell me when it comes back. And eventually you get your result. And then in your loop, you call the next REST API, and the CPU and the network are also bored, and eventually you get done. But that's a lot of waste, because the CPU and network don't need to be bored. You want them to be busy working. So you really want to do this stuff in parallel. And that's why you need threads. So why do you need virtual threads? Well, when I have a virtual thread, it's a lot less heavyweight. So I've got my platform threads here, and they do my 2 REST calls in parallel, and that's good because the CPU isn't quite as bored, but it's still kind of bored because it can handle way more than 2 threads. We're waiting for this REST API. That's going to be a second, right? And in CPU time, a second is enough time to take out a pillow and a sleeping bag and have a good nap. With virtual threads, you're calling them, but the platform thread is able to handle essentially as many virtual threads as you want because the platform thread, aka the real thread, the one that was bored, is only doing something when it has a virtual thread. So it says, okay, virtual thread 1, go make this network call. I'm going to put you over here. When you're done, I'll get you back, or at least someone will. And it keeps doing that. So it can spawn hundreds or thousands or however many you need virtual threads without using up extra resources. And when the network call comes back, the next platform thread that's available is like, ooh, virtual thread 1 is done. I'll go process the result. This results in being able to do a ton more work. And it's amazing when you run it, the speed difference, because we don't realize how heavy these platform threads are because we're so used to them, but you can get so much work done. You've essentially made it so your program isn't CPU bound anymore. Unless your threads are doing CPU calculations, in which case you shouldn't use virtual threads because they won't buy you anything. But if you're bound by any other resource, I/O, disk, network, CPU, no problem. Not CPU, sorry, not CPU, very much not CPU. Network, anything that is not CPU, virtual threads will help you. So platform threads are the threads we've had forever, and they're pretty heavyweight. They're tied to actual OS threads, which is why they're heavyweight. Your computer can only support so many threads. It's a big number, I will grant you that, but it is a number. And often they're pooled because they're heavyweight, so we don't want to keep using them. Luckily, virtual threads are also instances of Java Lang thread, so we're able to use them. And what's cool about virtual threads is because they're so lightweight, they're often short-lived and throwaway. You have a virtual thread do one thing, it gets garbage collected, it's done. You don't have to pull or reuse them in order to optimize because the compiler does it for you. So we have our executors. Executor service became auto-closable a couple of releases ago, so you don't have to deal with the whole shutdown mess anymore, which is great. When you're creating it, you can create using the first 3, which give you platform threads, or the 4th one, new virtual thread per task executor, which does what it sounds like, it gives you a virtual thread. Shutdown is the one that says there are no tasks, but you can finish the one you have. And that's what you get with auto-closable without specifying anything else. Shutdown now is like, nope, I don't even want you to run the stuff you're running, and that one you have to close explicitly, and close calls shutdown because it needs to be named closed for auto-closable, and since it was added afterwards, shutdown already existed. If you do need to create a thread directly without using an executor service, you can call thread.aVirtual, and it will give you a virtual thread. There is no constructor that you can use to give you a virtual thread. So if you see new thread, it's a platform thread no matter what. So what about scope values? You keep hearing about scope values. And scope values are great because they're not on the Java 21 exam. Yep, scope values are complicated, so I'm not looking forward to this presentation in a year or 2 where I actually have to understand them and talk about them. But for right now, problem solved. Also, Scott likes concurrency more than me, so I think he's going to write the scope value chapter, and I'm going to learn it by reading it and editing it. Locale added a new method, locale.of, which has nothing to do with concurrency, but I wanted to show off its existence. So new method, it's easier to read and understand. And it works well with all of the compact formatter stuff, which allows you to write in plain English what is going on with your output. For those of you who are from other countries, sorry, we've got miles. Okay, we've got a handful of practice questions and then questions from you. So to create a virtual thread, you can only use C or E. You cannot use new virtual thread. That is not a thing. Create a platform thread, A, D, and F. This is not new. You can call new thread. Here with do stuff, it is that do stuff is completed because if my try with resources has successfully completed, it called shutdown, which waited for the thread to complete. Super nice. And the last question, which we are going to participate in, raise your hand if A is true and you learn stuff. Yay! I have 2 more slides that have nothing to do with the cert. UTF-8 is now the default character set when reading a file. So if you use different character sets, be aware of that. That behavior changed. String builder and string buffer have a repeat method, which is good when you're writing unit tests and need long strings. String split with delimiters now has a limit, which is nice because you can specify what's going on. And finalization from garbage collection is deprecated for removal, so it might go away one day. Also, JavaDoc changed. You're now able to write more readable JavaDocs. And my favorite is you can have code snippets. So you can have your JavaDoc include things that's in an actual file instead of having to specify everything in HTML like we saw this morning. That completes my presentation. I'm going to say I'm done, so anyone who wants to get beer can, and anyone who wants to ask me a question can come up here and ask it. Thank you all for coming.